Okay, we're in A2U2L7a, linear inequalities. An inequality is worked pretty much the same way as an equation. It's just that we're going to have the greater than, less than, greater than, equal to, less than, or equal to signs. And remember, the one thing is, if you multiply or divide by a negative number, you flip your sign. All right, let's take this example, and we want to see if any of these 3 points are the solutions for this. Remember, when you have 2 variables in an equation or an inequality, you have the possibility or the probability that there will be more than one answer. All right, one variable depends on the other. So first, when you have an ordered pair, remember the first number always corresponds to x and the second to y. So that's how we're going to fill these in. Let's take our inequality and we're going to put 4 in for y. So I have 4 is greater than or equal to negative 2 times 7 plus 9. So 4 is greater than or equal to negative 14 plus 9. 4 is greater than or equal to negative 5. And this is a true statement, so yes, that is a solution. All right, let's do the same thing with this. Here's x and y. So I've got 3 equals negative 2 times negative 1 plus 9. Oh, that's greater than or equal to. All right, 3 is greater than or equal to 2 plus 9. 3 is greater than or equal to 11. 3 is not greater than or equal to, so that is not a solution. And then let's check this one. We're going to have negative 5 is greater than or equal to negative 2 times 10 plus 9. So I have negative 5 is greater than or equal to negative 20 plus 9. Negative 5 is greater than or equal to negative 11. Now remember, on the negative side, the numbers, the larger seemingly the number is, the less value it has. So this is true, and it's a yes, because negative 5 is greater than negative 11. Okay, let's have a look at a real world problem. John sells t-shirts. His plain shirts cost $5 and his graphic shirts cost $7. In order to match his product costs, he must make at least $1,200. So we're going to write an inequality to represent this situation, and we're going to let P represent the number of plain shirts he sells, and G is going to be the number of graphic shirts that he sells. So the price of each plain shirt times the number that he sells, which is P, will be the total sales from those, plus $7 times the number of graphic shirts he sells. And we want this to be greater than or equal to $1,200. All right. Now, part B says if he sells 150 plain shirts and 60 graphic shirts, is he going to make his quota? Is he going to sell what he needs to? So we're going to take our inequality and we're going to put the 150 in for P, and then we're going to put the 60 in for G, and we're going to simplify it and see if he made enough money. So 5 times 150 is 750. 7 times 60 is 420. And when we add 750 and 420, we get $1,170. Is that greater than or equal to $1,200? No. So he did not make enough money. Part C says he sells 90 graphic shirts. So let's just put that over here. And how many plain shirts would he have to sell in order to make his $1,200? So our inequality now would be 5P, because I don't know how many he's selling there. He's going to sell 90 graphics. So that's $7 times the 90 that he sold. Is this greater than or equal to $1,200? All right, we're just going to solve 7. We've got 5P plus 7 times 90 is 630. Then we would subtract 630 from each side, and that's going to give us 570. Divide both sides by 5, and P is greater than or equal to 114. So he would have to sell at least 114 plain shirts just to break even. Okay, let's look at number 1. We want to graph this inequality. Fortunately, it's already in slope-intercept form, so it won't be difficult to graph. We're going to have a y-intercept at -1, so let's put a dot right there. Now, our rise run is 2/3, so we're going to rise 2 and run 3. And if you want to put another one, you can rise 2 and run 3 again. So here's our line. Now, the first thing is, do you put a solid line or a dotted line? If it is less than or greater than, you're going to put a dotted line. If it's greater than or equal to, less than or equal to, you put a solid line. Okay, it's kind of like your dots. If you have less than or greater than, use an open dot. So we're going to use a dotted line on up through there. All right, now, what that line did is it cut your graph into 2 areas. When you solve an inequality, you get a whole area, not just a line. So we have to decide, is the solution in the upper part of our graph or in the lower? And we're going to shade the appropriate part. So what I do, and there's a lot of different ways people think of to determine this. One of the easiest for me is you pick a point in one of the 2 areas. If possible, I usually pick the point 0, 0. And I say, if possible, if your line runs right through that point, then you can't use it. But fortunately here, the 0, 0 is on the upper part. So what you do is you fill in the x and y for x and y. So if I had 0 is less than 2/3 times 0 minus 1, 0 is less than -1. Is 0 less than -1? No. 0 is greater than all negative numbers. So the numbers in this area don't work. This is a false statement. So I would shade the other side of the graph. And if you want to check it, you can pick any number on this side of the graph, fill it in for x and y, or any point, and fill them in for x and y, and you'll get a true statement. Let's look at number 2. Okay, so for number 2, y is greater than or equal to -4. Once again, we're in slope-intercept form. So what is my y-intercept here? Well, if there's nothing there, it's understood to be 0. And my slope is going to be -4 over 1. So let's put a point here at 0. And to rise run -4 over 1, I'm going to go down 4 and over 1. And I'll go ahead and put another point. Okay. Now, determine whether you need a dotted line or a solid line. Since this has the equals to, we're going to need a solid line right up through here. It's okay if you're a little bit off because we're looking for regions now. Okay, now I need to decide, am I going to shade in the top part or the right-hand part or this part down here? So just pick a point. Here is +1, 1. So I'll pick that point. See, this time 0, 0 was out because the line goes straight through it. So I'm going to pick 1, 1. If I substitute 1, 1 in here, let's see what we get. You don't have to put the +0. So is 1 greater than or equal to -4? Yeah, +1 is greater than -4. So I'm going to shade the area that contains that point. And there's your graph. Okay, let's look at number 3. 5x plus 3y is less than or equal to 12. We're not in slope-intercept form, so you could either make an xy chart and pick some numbers and graph it, or what I'm going to do, let's just go ahead and put it in slope-intercept form. Subtract 5x from each side is going to give us 3y is less than or equal to -5x plus 12. Then we're going to divide all the way through by 3, so y is less than or equal to -5/3 plus 4. 12 divided by 3 is 4. All right, and that's x. Now on your slope, remember, if you have a negative slope, you can either make it -5 over 3 or 5 over -3. When you have a negative out front, it can go to the top or to the bottom, just not both. So now to graph this, our y-intercept is at +4, so we're going to go up 4, 1, 2, 3, 4, and put a dot. Now for our slope, we're going to use rise over run. So we're going to rise -5, 1, 2, 3, 4, 5, and then we're going to run 3, 1, 2, 3. So here we go. Now, do I want a solid line or a dotted line? Since I have less than or equal to, I'm going to use a solid line right there. And now I just need to decide which side to shade. So I'm going to pick a point on either side. This one allows me to choose the point 0, 0. Now if I take 0, 0 and fill it in for x and y, I have 5 times 0 plus 3 times 0 is less than or equal to 12. So 0 is less than or equal to 12. Is this a true statement? Yes, it is. So this point makes a true statement. So I'm going to shade the area that contains that point. Okay, let's look at number 4. Okay, let's look at number 4. X minus 6y is less than -12. So let's just go slow and be careful. We're going to get this into slope-intercept form first of all. So let me subtract x from each side. And that's going to give me -6y is less than -x minus 12. Then I'm going to divide all the way through by -6. Now when you divide by a negative number, you flip your sign. All right, negative over negative is positive, and negative over negative is positive 2. Now we want this to be in the form of rise, run, a slope. So we talked a while back about anytime you have a variable over a number, you can rewrite that as 1 over the number times your variable. So x over 6 is the same thing as 1/6 x, and this gives us it in rise, run format. All right, let's go to y and put a point at +2. That's our intercept. And then we're going to rise 1 and run 6. 1, 2, 3, 4, 5, 6. So there's our other point. Now since it's just a greater than, we are going to need a dotted line, not a solid. Now we need to figure out, do we shade the upper portion or the lower portion? So let's just pick a point. Our 0, 0 is well in place, so we'll pick that. And we're going to fill it in up here. So if I take 0 minus 6 times 0 less than -12. Well, this is 0 minus 0. So is 0 less than -12? No, it is not. So this area is not a solution. That's a no. So I just want to shade the other area. Okay. Okay, here's number 5. 9x plus 12y is greater than or equal to -60. So first let's get it into slope-intercept form. We're going to subtract 9x from each side. So I have -9x minus 60. Then I'm going to divide all the way through by 12. So now I have y is greater than or equal to, and this is going to be -9/12 x. So let's just go ahead and reduce that to 3/4 x. And then 60 divided by 12 is 5. So we're ready to graph. Now my y-intercept is going to be at -5. 1, 2, 3, 4, 5. So here's that point. And my slope is -3/4. So I can either do -3/4 or I can do 3 -4. Whichever one is going to keep you on your graph better. So let's go down 3, 1, 2, 3, and then run 4. 1, 2, 3, 4. Here's my next point. All right, and you can see if I had used the other one, if I rise 3 and then run backwards 4, you see it's just the other part of the same line. All right, since I have greater than or equal to, I am going to use a solid line, just like this. Now I just need to determine, do I need the upper part of my graph or the lower? So if I go back, if I pick 0, 0 in that part right there, and I plug that in, I have 0 plus 0. Well, is 0 greater than or equal to -60? Yes, it is. So I would shade the part of the graph that includes that point. Okay, let's look at number 6. Okay, x is less than -4. Now, when we have an equation of a line that just has an x or just has a y, we know that we have either a horizontal line or a vertical line. X less than some number is a vertical line straight up and down at that point. So if I go to the x axis and I go to -4, 1, 2, 3, 4, put a dot. All right, since this is less than, I'm going to need a dotted line. So it's just going to go straight up and straight down. So now we need to shade one side or the other. Pick your point. I'm going to take that 0, 0. Now I only need the x coordinate. So if I put 0 is less than -4, is that true? No, 0 is not less than 4. 0 is greater than 4. So I'm going to shade in the area that does not contain the point that I tested.